PowerPoint slide will be available, will be posted on Blackboard after class today. So I will give you all the solutions, and also, as you can see, what we're going to cover in exam 2, those sections and the topics. And I also indicated which week we covered this topic. And so if you need more, if you want to review the videos, the class videos, watch those class videos again. And you can say if you have trouble solve equations of higher degrees and you want to look at some more examples and do some more practice, so you can go to week 6 and watch the class videos. So all the class videos are posted on Blackboard. Okay, you should be able to access, click on the link and watch the videos. If you cannot access it, any video, just email to me. I can download those videos and upload them to YouTube, and that way you can watch it. Okay, so if you're a class member, you should be able to click on the link, you should be able to watch them. But sometimes I don't know what's the problem. Sometimes you can't, it just says you don't have access, and then in that case you can email me. All right, okay, so these are the problems we're gonna have. These pretty much everything I listed here, we have at least one problem for that type of question. Okay, so let's look at the first one. So I also put like this question, where does it come from? If you say I missed the first one, I didn't do it right, and you need more practice or videos, that's from section 4.2, multiply and simplify rational expressions. Okay, so in this case, we have the only operation we have is multiplication. So we have a lot of operations, but all of them are multiplications. See, times, 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 and times between them, times, times, times. Okay, so we are going to, if it's all multiplication, we can cancel the factors. Each of them is called a factor. When we reduce, we can cancel factors. For numbers, I did see maybe there's 1 or 2 students who multiply the numbers out. 8 times 14 equals 112. Wait, I'm sorry. 112. And 7 times 6 is 42, and left the numbers that way. And you do have to reduce the numbers. Okay. There are different ways to do this question, but usually I will put the numbers together and leave them alone, and so I can reduce. For the variables, I recommend that you multiply them out, multiply all the variables, x squared and y to the 4th, by using the exponent rules. Okay, because we know x squared, well, I'm sorry, x squared is just by itself, and y to the 3rd times y, it's going to give you y to the 4th. Oops, let me mute my email. Okay, so let's see. And the bottom, we have x times x, which is x squared and y squared. I mean, yes, you can just cross out x and y's directly from the original problem, but sometimes you may make mistakes. So usually I would recommend that you multiply all the x's together, y's, and from the top and from the bottom. And after that, we can reduce. Let me change the color. So we see that 7 goes into 14 2 times, and 6 and 8, they both have a common factor 3. So we divide both of them by 2. Divide both of them by 2. That's what we have. Okay, the numbers, that's all we can reduce. And 4 multiplied straight across, 4 times 2 is 8. And 3 will be by itself. Now x squared cancels x squared. Y4 divided by y squared, we know we get y squared because 4 minus 2. Well, you can cancel out 2 copies of y's. Either use the formula to do the exponent, subtraction of exponents, 4 minus 2. Okay, so that's the first one. In this question, we didn't have to do any factoring because everything is already a factor. 8 is a factor, 14 is a factor, x squared, y 4th. You can cancel factors out directly. But in the second example, we cannot cancel them directly because we have plus, plus, and a plus. These plus signs will stop us from canceling anything out because they are not factors. Okay, 4 is not a factor of the top. It is a factor of the first term, but it's not a factor of the top. So you won't be able to cancel this 4 and the 16 or x squared and x fourth. So these questions, I wrote down the steps here. First, you got to factor, and then you cancel common factors and multiply the rest of the factors out. And recall the factoring question we did before on the first exam. We have 4 of them, GCF, and we have difference of 2 squares. And we have trinomial grouping. We also have trinomial. Okay, grouping. So whenever you get a factoring question, so how do I factor the top? I always start with GCF to see if they have anything in common. And apparently they have x third in common. So we factor out x third. And to write down the other one, you just have to do division. So you take 4x to the fourth, divide by x third. That gives us 4x, because x fourth divided by x third, that's x. And similarly, you take 5x third divided by x third, and that gives you a plus 5. Okay. All right. The bottom, notice that they don't have anything in common. 16, 14, 25, there's nothing, no GCF except 1. X squared, x, no x. So there's no GCF. It's not going to be type 1. And for the rest of them, it's easy to determine. If you have 2 terms, and check whether it's difference to 2 squares. If you have 3 terms, you check whether it's a trinomial. And in this case, we have exactly 1, 2, 3 terms. So to factor that, and there are different ways to do. So the way I taught in class is to break down 16x squared. Get a 4 times 4 is 16. X times x is x squared. And break down 25, that gives us positive 5 times positive 5. And make sure the cross products, 4x times the diagonals, 4x times 5 is 20x, 4x times 5 is 20x. And after you add them, you should be able to get the term in the middle, 40x. If it does give you 40x, that means this factoring is correct. Otherwise, it's incorrect. Okay, so we are going to write the factors horizontally, 4x plus 5 times 4x plus 5. And after, that's our first step. The second step is to cancel common factors. Notice that they all have 4x plus 5 in common. See, that's a multiplication, that's multiplication, which makes them factors. And we can write down, there's nothing to multiply after we cancel the common factors. So that's just the final answer. Okay, this third one is also similar, but we have a division. The first thing we got to do is, how do we divide fractions? Keep, change, flip. We did this on the first exam. Okay, so now we have variables in here. So the first step, I would do that. Just keep the first fraction and change this to multiplication and flip the second fraction. Now, after this, we are going to do factors, just like follow the steps right here. So we're going to have to factor all the numerators, all the denominators. Now, the factoring types start with GCF always. So they have a 5t in common and divide both of them by 5t. So you would take 10t third divided by 5t. That gives us 2t squared. And you're going to take 25t divided by 5t. So that gives us 5. Okay. Now the bottom also has a common factor 10. So we take 10 out, divide both of them by 10. So we get a 2t plus 5. Okay. And right hand side, I mean the second fraction, the top is a trinomial because they don't have any GCF, and that's a trinomial. So break down 2t squared and put in the first column 1 times 2, t times t. And for -1, we have -1 times +1. And again, the diagonals has to add up to the term in the middle. So notice -2 plus 1 is -1t. So that does match the one in the middle. So the factoring of the top is going to be t minus 1 times 2t plus 1. Okay, so on the second exam, I won't give you any question, just say factor this, factor that. But as you can see, a lot of questions you do still have to do factoring. So like the second one and the third one, and also there's 2 equations that you also need to do factoring. The bottom, a few students missed the factoring of the bottom. So how do we factor the bottom? Again, start with GCF, and we see that they have a t in common. So we factor out a t. Now t fifth divided by t, that's t fourth, and t divided by t, it's 1. And many students just left it as t fourth minus 1. And notice this is difference of 2 squares. You should be able to factor this further. And how do we factor t fourth minus 1? You can write it as t squared and minus 1 squared. So that's difference 2 squares. Okay, t squared plus 1 times t squared minus 1. And again, t squared minus 1 is also difference of 2 squares. But be careful, t squared plus 1, it's not difference of 2 squares. Apparently, we don't have difference. We have the sum of 2 squares. Unfortunately, we don't have a formula. We cannot factor the sum of 2 squares. But we can factor difference of 2 squares. And that one, you can also write 1 as 1 squared. So again, difference of 2 squares. So you will get another 2 factors of t plus 1 and t times t minus 1. All right, so that would be the factoring part for this. I'm gonna maybe just go ahead and put the factoring part here to save some writing. And you can also do all this work on your scratch paper and just write down the final answer here. So t squared, I'm gonna copy this answer and put it here. Okay, but I do need you to show when you take the exam, again, just like the first exam, you have to write down all your work on your paper. So I do need to show all the factorings you did. Okay, I noticed some students didn't write down they just kind of just canceled them already. I don't know how you did that, but you do need to show them and just show which ones you cancel them out. For example, t minus 1 cancels t minus 1. Oh, sorry, I have plus 1 here. I made a mistake. Okay, so divide by 10. 10 divided by 10 is 1. So 2t plus 1 cancels 2t plus 1. And this t cancels this t, and this 5 goes into 10 2 times. And notice that's all we can cancel, and so we end up with and we can multiply whatever left. There's a 2 in the denominator, 2 squared plus 1, and t squared plus 1, and t plus 1, and the top, there's only 2t squared plus 5. Some students, actually, a lot of students multiply this out. I mean, it's fine if you do that, and just don't make any mistakes when you multiply them out, but you can leave them as it is. Okay, so you don't actually have to multiply them out. All right, so the important steps are factoring and cross out common factors. Okay.
You be posting the video because I missed the first 1A because I logged on a few minutes late.
Yeah, that's fine. Yeah, the videos will be posted. And also this PowerPoint slide will also be posted. Okay. And also, I don't know if you were late, I mentioned that the exam this time will be different. You will come to the class and take the exam, okay? Because proctor track is unavailable. All right, so now let's look at the next question. And this time it's add and subtract. So we have addition, subtraction. Similar to adding, subtracting fractions, we have to find the LCD and equal the denominators, and then we did add or subtract fractions, only numbers in the first exam, but this time we have variables. Okay, so find the LCD. Hopefully at this time, okay, again, if you say I need more examples to watch, and go to 4.3, okay, so section 4.3. And which week did we cover 4.3? You look at 4.3. It's, right here. It's it's under week 7. So that way you can find a video, more examples for this type of question. So let's continue here. To find LCD, if you can see what LCD is, of course, in this case, I gave you a tip in class how to find the LCD quickly. So you look at the numbers 2 and 3. Okay, that'd be 6. 2 and 3 both going to 6. And you look at the variables and you pick the one with the highest exponent, but both are x, right? So let's just keep x. So that was the tip I gave in class. But if you forgot that, how to do that, you will just have to break down everything. X, I cannot break it down. 2, I cannot break it down. Create a new column for that. 3x can be broken down as x times 3. And to look for LCM, you bring down 1 from each column. So that gives you 6x. That matches what we got by looking at them. So the tip is, you first look at numbers. All the numbers you have. Like here, we only have 2 and 3, right? So what's the LCM? LCD means LCM of denominators. Okay, of denominators. So pretty much it's looking for the LCM of 2 and 3, which is 6. If you can see that, do that in your mind. And for the variables, it's very easy. Pick the one with the lowest exponent. Because they're equal, they have the same exponent of 1. So of course, you just pick that. Okay, so that's the quick way. And this is the slow way here to look for the LCM. So once I found the LCM or LCD, which is 6x, I'm going to decide what I need to multiply. Let me clear all that. And I will, okay, to get 6, I multiply by both top and bottom by 6 here, because that's going to give me 6x and 30. To get 6x, I need a 3 and x. So times by 3x. And 2 times 3 is 6. X will keep it. 7 times 3 is 21. X times x is x squared. Now for the last one, I think maybe I saw one student made a mistake because we already have x. You don't need another x. You just need to multiply by 2. I think, was that Stephanie? I forgot somebody multiplied by 2x. Okay, I can't remember who did that. So we are going to get 6x and 4 on the top. Okay, and then the last step is to keep the denominator, okay, and add the numerators. Okay, so the denominator is 6x. We keep it. Add the numerators. So it's 30 plus 21. And this step can be omitted if you can do that in your mind. And 30 minus 4 is 26 plus 21 x squared. So that would be the final answer. Okay, questions? Now the next one is also addition subtraction, but this time the denominators cannot be factored. Okay, so previously if you see this example, 3 times x, you can actually factor it as x times 3. Okay, in the homework we actually did more complicated ones than these. Like we did like 6a squared, b third, something like that. But it's all, you can all factor this. It's all multiplication. You can break down as 2 times 3, a squared is a times a, b squared is b. So that's what we had in the homework. But everything can be factored further. I mean, not everything. Most of the things can be factored further, and you only have multiplication in the denominator. But in the next example, notice that we have a plus, right? And notice that if you try to do the same way, so how do I break this down? I remember when we had this class, a few students had trouble with this. To find, I know some of the students might be able to see, like to use the tip that I gave you to find the LCD quickly, right? But for this one, there's still a quick way, but be careful. You cannot look at the 5x and the 6 separately. 5x plus 6, they're together. They cannot be factored. Think about the factoring types we did. There's no GCF. It's not difference of two squares. You cannot do, it's not a trinomial grouping. And actually x, look, you cannot break down x, okay? If you have x squared, you can break down x squared as x times x. But if you have x, there's no way you can break down x. So 5x plus 6 is not factorable. You're going to have to keep it. So if I ask you, what goes into 5x plus 6? only itself, and only one and itself, okay? Don't say 5 goes in here. No, 5 doesn't go in here, okay? If I change this plus to multiplication, okay, you can say 5 goes into this, x goes into this, 6 goes into this. But when with the plus sign here, nothing goes in here except 1 and itself, 5x plus 6. Okay, so that's something you got to remember. Similarly, for x plus 2, you cannot break it down. What can go into x plus 2? Only 1 and x plus 2. Okay, so we look for, we bring one factor down from each column. So we will have 5x plus 6 as a factor and x plus 2 as a factor and multiply them. So look, what is the LCD? It's just going to be the product of these two. Okay, so the tip is if neither of them is factorable, the LCD must be the product of these two. So you just need to multiply them. Okay, again, don't look at them separately as a 5x and a 6. No, 5x is not a factor. 6 is not a factor because of the plus sign here. Okay, down. So you have to look at the x plus 2 as a whole factor. Okay, so we can multiply what we need. So in the first case, in the first fraction, our denominator already has one of the factors, which is 5x plus 6. I just need another one, so we multiply by x plus 2. In the second case, the denominator already has x plus 2. We just need the other one, which is 5x plus 6. Okay, so let's multiply by both top and bottom, multiply by 5x plus 6. A few students made mistakes in the subtraction. So again, one more time, I think there were at least like 5 students made this mistake. Okay, so when this minus sign goes, you need to be applied to both. Okay, this minus, if it goes in front of the second fraction, it needs to be applied to this term and that term. Okay, so I think many students had still had a plus here. So let me work this out. So now we have a common factor, 5x plus 6 times x plus 2. Now we can, I'm going to actually slow down and write down this step to show you. Maybe with this format, it's hard to see why this minus needs to be applied to both of them. But if I apply the rule, so I keep the denominator, do the top minus the top, and you can see better why when you distribute, this minus sign needs to be distributed to both. Okay, so now I'm going to do one more step to do multiplication. So this step, yes, you can omit that, but if you look at your practice exam, if you made a mistake in the sign here, I circled it there for you. And if you made that mistake, when you take the exam, you should do what I did. Write down this step. Don't skip this step, because if you do, if you tend to make mistakes. So now we do FOIL. So we end up with the x squared plus 2x minus 1x minus 2. So no problem with that. But the next part is negative x times 5x. That's negative 5x squared. Everybody got that one right. But for the last term, it should be negative times positive. That gives us negative 6x. Okay, so the place that I said many students made a mistake was this minus sign right here. Okay, a few students may have had a plus here because they're thinking, oh, well, it's x times positive 6. That should give me positive 6x. They didn't realize this minus sign actually needs to be distributed through. Okay. All right, so now we can write down the final combined like terms. The bottom, you can leave it. You don't have to multiply this out. Just leave it. The top, we have x squared minus 5x squared. That's negative 4x squared. 2x minus x, that's x. X minus 6x, that's negative 7x. And there is a minus 2. Okay, so that was the one, a few students made a mistake. Okay, questions? Now let's look at the next type of question. 1F, which is notice it's multiplication. So we don't have any. Again, on top of each question, I listed this which section it comes from to help you, and to, if you need more practice questions, go to look at your homework. For homework problems for section 5.1, and you can get more practice questions that way. Okay, so like you say, I missed this one. I didn't know how to do this one on the practice exam, and or I made mistakes on this one, and then you just go. Of course, I will give you solutions now, but if you need more practice, besides redoing this one, you can also find more practice from section 5.1 in the homework or from the textbook. Okay, so it's multiplication, 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 multiplication. And so this is like multiply expressions. The new thing is negative exponents. We did do this in the first exam, if you remember, but at that time we did not have -3, -1 as exponent. Okay, so the way to do it, it's exactly the same. Because we have all multiplications, that means you can actually switch the factors around. You can put 9 and a -2/3 together to multiply them, because neither of these three can be multiplied. Neither of them can be multiplied, but I can move things around, like switch factors, these two together, and a to the -3rd times a squared, and put b to the -1st and b to the 4th together, because they can be multiplied, they can be multiplied, they can be multiplied. This step can be omitted. You can do this in your mind, but if you have trouble, you can write it down. Okay, now let's simplify the fraction. Reduce this, so you get multiplied straight across, -6. Now, how do we multiply a to -3 times a squared? That's the formula that we had before. Okay, in the textbook, they give you different ways. In one class recently, I actually asked you guys to do all of these in forms. I gave you a link and asked you to give me the answers, and that was the one. This was the one I asked to do. Okay, because these formulas are really very basic formulas in algebra. Okay, so corresponds to these formulas from. Okay, the reason I use the very different symbols is because it makes it easier for me to refer to them. So it's really, when we write the formulas this way, they just look very neat, very simple, but may not be easy for you to memorize. Okay, so when I memorize these formulas, I use sentences. So when I multiply two exponents with the base b, I keep the base b, I add the powers or exponents. So in the second case, if I have a power of power, I multiply the powers. So e means exponent, b means base. So if I have product in the base, I can raise each base to each factor in the base to that exponent. Okay, so similarly, if I have division, you can raise each one to the exponent. Again, if it's plus, if I change it to plus or minus, please don't raise each of them to the exponent. This is wrong. Okay, one more time. On the first exam, some students try to do that. That's incorrect. Okay, just like we had question x plus 2 to the 3rd. You cannot just say, I do x to the 3rd plus 2 to the 3rd. That's incorrect. Look at the formulas we have. All of them involve multiplication or division. There's no formula for addition or subtraction. So there's no such formula. Okay, so don't use that formula. Okay, so now we go back here. How do we add them? We found the formula, which is the first case. See, base a times base a with exponents. We keep the base a, whatever the base is, you keep it, and you just add the exponents. So it's going to be -3 plus 2. Again, you can skip the step. You can do this in your mind or use a calculator. -3 plus 2 is -1, right? So you can go ahead and do that. I'm going to slow down here because later, if anybody has trouble to see how did you get -1, that's what I did. And how did you get a +3? Because -1 plus 4 is +3. Okay, you can leave your answer this way. Or I know a lot of students got rid of the negative exponent. You flip to the bottom. So negative 6b third will stay in the numerator, but a to the first will be flipped to the bottom. Okay. Any question here? So notice this minus sign, it's not in the exponent. Don't flip this one. Negative 6 stays. And the only time you can flip anything is if there's a minus in the exponent. All right, the next question is gonna, whoops, did I skip one? No, okay. The next one is the radicals, combining radicals. First, you have to simplify all the radicals because when can we combine radicals? They must match. You cannot, if I give you something like this, you cannot subtract them directly. You can only add or subtract the same radical. It has to match. So 12 and 27, they don't match, but I can simplify them to see if they end up being the same. Notice square root 12. Now that part can be done on your scratch paper. So 12 is 2 times 2 times 3. And 2 copies of 2 comes out to get a single 2. The single 3 stays with the radical sign. So that's what we got for that. 5 over 2 times, let me use a different color for that. For that 2 square root 3. Okay, so I just simplified the square root of 12. And I got 2 square root 2. Similarly, we should simplify square root 27 and break it down 3, 3, 3. And 2 copies of 3 comes out to get a single 3, and the other single 3 stays with the okay, so and minus 2 times. Okay, again, there's nothing between 5 and the radical 12. That's multiplication. So that's why I have multiplication here, Okay, so the radicals, as you can see, after I simplify both of them, I got radical 3. They match. In the homework, we did one which was much more complicated than this. You have to deal with the fractions, but in this case, 2 cancels 2. 2 times 3 is 6, cancel 6. You actually end up with the whole numbers in front of the radical, with integers in front of radical. You didn't have any fraction. So 5 minus, now there's nothing in front of radical 3, which means 1. So 5 copies of radical 3 minus 1 copy of radical 3, we get 4 copies of radical 3 because 4 minus 1 is 4. 5 minus 1 is 4. Okay, if you somehow get fractions here, then you have to you will have to subtract the fractions. For example, oops. Okay, so if you have a fraction here or fraction there, you just have to subtract these 2 fractions to put whatever answer in front of the radical. Okay. All right. Next question will be from section 5.2. We still want to simplify the radicals, but one of the rules of a simplest form of a radical is no radical in the denominator. Secondly, you cannot have 2 copies. So usually, I mean, there are 2 ways to do this. The way I usually prefer is to simplify the radical first, because x to the third actually contains x, x, x. You can get 2 copies out. So that's what I usually recommend that you do. So that 3 will stay. Okay, that 3 stays with the radical, but so let me put that 3 there. So you can simplify the bottom to x times radical 3x, and then try to get rid of radical in the denominator. And we know that we can multiply by another copy of square root of 3x. Okay, the top, since one number is outside the radical, the other is with the radical, and you cannot really multiply them, just leave them. But the bottom, both are with the radical, you can multiply them, and we know that gives us 3x. Okay, because when you put them together, you're going to get, let me write it down here. So when you put 3x times 3x, you got 2 copies of 3 that can come out. 2 copies of x that can come out. So radical sign is gone, and you just get 3x. Okay. The bottom, 3x times x, 3x squared. And the top would be 4 radical 3x. So that's the final answer. I did see a few students did the other way. They went ahead, they didn't simplify the radical. They went ahead and multiplied the same copy. Okay, so if you did this, it's correct, but make sure you simplify your final answer. So if you did this, 3x third times 3x third, you will get 3x third. Okay, because you have 2 copies of 3 that can come out to get that 3, 2 copies of x third that can come out to get x third. Okay, but you cannot stop right here. I think I saw students who did this way and just stopped right there, which is incorrect because look, x to the third, it has 2 copies of x in there. That needs to be simplified because we always want your answer to be in the simplest form. So you need to continue to simplify this radical, and I just did it right here. So that should be the answer here. So 4x times radical 3x. And notice there's an x in the denominator. X, they have a common factor x, and cancel one of them. So the final answer should be 3x squared 4 radical 3x. So as you can see, we get the same answer. Okay, but I think the first way solution is easier. Solution 1. Okay. All right, questions? So this step right here, this process what we just did is called rationalize the denominator. The reason we call it rationalize because originally with the radical sign, we also called it irrational. Radical is irrational. And the final answer, look, we have 3x squared, no radical anymore. That becomes rational. So this process of changing an irrational denominator to a rational denominator is called rationalize the denominator. Okay, there is another case of this. What if I have a plus or minus in the denominator? So again, I actually gave you, in class, I gave you several problems to compare. Eventually, we figured out the only way to get rid of radicals in the denominator if there's a plus or minus sign is to multiply the conjugate. Okay, so for this case, if you see a minus or plus, different from the previous case. Previous case, there's only multiplication. There's no plus or minus. You can always multiply another copy of itself. It's always going to work to get rid of the radical. See, the next step, no radical anymore. But if you have minus or plus in the denominator, the only way to get rid of radicals is to multiply both the top and the bottom by the what we call the conjugate. And again, I mentioned in class that if you are going to take calculus class, this is an idea that will also be used in your calculus class. Okay, so multiply both the top and the bottom by square root. What is a conjugate? Conjugate means you are going to keep the first term and the second term, but switch the sign. Change the sign between them. If it's minus, you would change it to plus. If it's a plus, you change it to minus. Most students did do right. I did see 1 or 2 students multiply the same copy with the same minus. If you have minus, you're not going to be able to get rid of the radical. Okay, so let's multiply them out. Let me get rid of those lines. So when we multiply the bottom, well, you can do the top of the bottom, it doesn't matter. So if you do the top, some students messed up the top. I don't know why. This is distributive property, right? Because you have a 4 and you're going to multiply top by top, and the second top has 2 terms. So which means you have to do 4 times radical 3 plus 4 times radical x. Oh, I think I remember one student put a 12 there. I forgot if I marked it or not. Okay, so it's radical 3. You cannot multiply 4 and that 3 with the radical sign. Okay, so you're just going to get 4 radical 3. And the bottom, we do FOIL, radical 3 times radical 3. Now, if you cannot do that in your mind, just write down everything. So radical 3 times radical 3. and plus radical 3 times radical x, and minus, because negative times positive is going to be negative radical x times radical 3, and then negative times negative is still going to be negative. It's going to be negative radical x times radical x. Okay, the bottom looks really complicated, but after you combine like terms, you will see like these two, they're exactly the same. Okay, one is positive, one is negative, so they will cancel out. Okay, because after you multiply these two, what do you get? Radical 3x. What do you multiply these two? You get radical 3x, and radical 3x minus radical 3x equals 0. So they will always be canceled. So that's the reason why you cannot multiply another copy of minus. If it's minus, if you multiply square radical 3 minus radical x, you're not going to get a one positive, one negative. You're going to have minus, minus. If you have minus, minus, they cannot cancel. You're going to get negative 2 of the radical, right? So that's why you've got to make sure they have opposite signs. So they will eventually cancel each other after you FOIL. Radical 3 times radical 3, that's just the 3, 2 copies of 3, right? And radical x times radical x, that's just going to be x because you got 2 copies of x out of the radical sign. And this minus sign stays. Okay. In the top, there's nothing we need to do, just copy it. And like I said, I don't know why a few students did not distribute 4 to both of them. They just did 4 radical 3 plus radical x. This 4 needs to be distributed. Okay, and again, why do we call this rationalize the denominator? Because originally you can see you have radicals, which is irrational, and the answer 3 minus x, no radicals, it's called rational. Okay, that numerators can contain radicals. It's just a rule that we don't want the denominators to contain radicals. Okay. All right. Now, next question is similar to the one we did before, like this one. Okay. The one we did in number 1F, it's multiplication, but this one is going to be division. Okay. So first, we are going to use the final formula, the last formula, to divide. So when we do division, we just split them into 3 division questions. 18 divided by 9, it's 2. Okay, but I did see mistake of dividing these 2 here and these 2 there. So by looking at the formula, when you do division, you can keep the base x, and you're going to subtract the top base, actually subtract the bottom from the top. We'll do top minus bottom. So the top is negative 2. The bottom is 3. And the sign operation we got to do is minus. Okay, so I think a few students did negative 2 plus 3 because this is division. You got to do subtraction. Negative 2 minus 3. Okay, similarly, for the second part, you're going to do 2 minus negative 4. This is kind of tricky, so you got to be careful. I keep the base y. I'm gonna do 2 negative 4. I think a few students just did a 2 minus 4, but there's another minus sign between them. Okay, this minus sign in red comes from the formula. The formula tells us to subtract the exponents, but that blue minus sign comes from the exponent of y. So there will be a minus minus there. So that's why I was saying this is tricky. So you just have to be very careful when you do this. Okay, so we end up with 2x to negative 2 minus 3, it's negative 5. 2 minus negative 4, you do keep, change, change. So that gives a y to the 6. Okay. Wait. Actually, did I have minus 2 as exponent or? It is minus 2. Okay. All right, so the next step, we could use this third formula because we have multiplication in the base. You can raise each of them to the exponent. A lot of steps can be omitted. For example, this one can be omitted. You may skip this step if you can do the subtraction in your mind. But if you didn't get negative 5 and 6, if you got like say 1 here and -2 here, you should write down the step because it means you didn't you couldn't do that in your mind. So because there are too many minus signs, so you should write down the step. Okay, or at least write it down on your scratch paper. So I'm going to raise 2 to -2 and raise x to -5 to -2nd and y6 to the -2nd. Again, this step can be done in your mind if you can. 2 to -2. So that's something we discussed before. How do we do 2 to -2? The definition is negative exponent means you flip. So it's pretty much you do 2 squared, which is 4, and you flip it to get a 1/4. So that one is just a 1/4. Now, x to -5 raised to -2. That is the second formula. When you have two exponents by each other, beside each other, you will multiply them. So -5 times -2 gives us a +10. And y6 to -2, that gives us y to -12. Maybe I shouldn't put this line though here. Okay, so there are two ways to write down your answer. 1/4 times x10th y to -12. Or if you don't like the negatives, you can flip to the bottom, y to 12, x to 10. So positive exponent stays in the numerator, negative exponent flips to the bottom to put together with the bottom 4 there. Okay. So these two questions are testing those formulas again, but with the negative exponents. Okay, in the final, you will get these again, and actually you're going to get fractions in your exponents. So for example, you may get -1/2 or -3/4 in your exponents, but you will still, apply these same formulas. Okay. All right, multiply. So that's from section 5.4. So you just distribute. Because multiplication outside, parentheses, subtraction inside. So when I multiply these two, now this step can be omitted. I'm slowing down here to show you all the steps, but you can skip this one. And when you multiply, you will have 2 times 6, 12, xy squared minus 18xy. Now don't leave your answer just like this because all the radicals need to be simplified. So 12, because it's 2 times 2 times 3, right? So you can get that 2 out. And that y squared is exactly 2 copies of y, so that can come out. So what we have left is just going to be 3 and that single letter x. Now similarly, that 18 is going to be 2 times 3 times 3. So you got 2 copies of 3 out. And there's a 2xy left. Okay, and notice that these two radicals don't match. They don't match, which means they cannot be combined. So you would just leave them. Okay, now that's also from the same, I think from the same, oh, this is from 5.4. So this one is from 5.3. We kind of already did it. If you have variables, okay, so first we can break down 54 as 2 times 3 times 3 times 3. And if you want to expand it, you can. But I gave you a tip in class how to do this quickly without expanding everything out. But I'll do both ways here. Okay, so remember the cube root needs to get 3 copies of something. So we're going to put 3, dividing into groups of 3. So that these 3 3s come out, you get a single 3. These 3 A's, you get a single A. These 3 B's, you get a B. And these 3 B's, you get a B. And now just write down whatever left. There's a 2, there's an A, 2, these ones single copies or 2 copies, and you keep them. And B times B, of course, is B squared. Okay, so keep a little distance here because that little cube is with the index for the radical, but that is the square of B. if you don't square, if you don't expand them, for numbers, you still have to expand them to factor them. But for the variables, as you can see, you're looking for groups of 3. So if I have 4 copies of A, how many groups of 3 can I get? So you take 4 divided by 3. That tells me that I can only get 1 group of 3 with 1 left. So that's why I have 1 group of A with 3 A's. 1 group of these 3, when we take them out, we're just going to get a single A. And for 7 copies of B, we divide them into groups of 3. So that gives me 2 groups of B's, B squared. And there's a single one left with the radical sign. Okay, so that's the quick way without expanding everything. Okay, questions? Now we are going to look at the equations. So on this exam, you are going to get this one. It's called, oh, I'm sorry, I forgot to change the title here. I will update this later. So this is actually solving equations, a rational equation. And solve a rational equation. I think it's from section 4.6. Okay. And well, I saw many students just kept all the fractions, dealing with fractions. If you're really good with fractions, fine, you can do that. But again, I don't recommend that way. So the way we taught in class was to find the LCD and get rid of the fractions. So first step, we look for the LCD. So we can use the quick way in a 2, 5, and 10. They all go into 10. And A, the lowest exponent of A is 1, so A to the first. So that would be our LCD, okay? Again, if you cannot see it, just break everything down. So 5A will be 5 times A, and 2 will just be a 2, cannot be factored. 10A can be factored as 5 times A times 2. And then you just bring one number or variable down from each column. So that's going to get you a 10A. Okay, so that's the slow way. But the quick way is look at the numbers and look at the variables. After I found LCD, I'm going to take 10A, multiply everything by 10A. So I do 10A here, 10A here, and 10A here. And notice that we're going to do the canceling part. So top A cancels bottom A. And 5 goes into 10 2 times. So notice that A is canceled out. We're left with the top 2 and this top 2. 2 times 2 is 4. Bottom all canceled out. This 2 goes into the 10 5 times and multiply straight across. 5A times 3, that's 15A. Because my writing might not be very clear. Maybe you can rewrite it, and so you can see that A is still there. Okay, be careful. Sometimes A is canceled out. Sometimes A is not. There's not an A here to cancel that A, so we still have that A there. And 10 cancels 10, A cancels A. So no A's anymore, so that's just a 7. Okay, so you get a very simple linear equation and divide both sides by 15. Again, this is the way I recommend. I'm not going to show you the other way, with dealing with all the subtraction, addition of fractions. Many students did that way. Maybe that's the way you learn in high school or the solution you found online. But again, that way is not as simple as this way. Okay, so that's the way we learned in the textbook and the way I usually prefer. Okay, now let's look at the next equation. So this is the equation from 3.7, solving equations of high degree. So we have a second exponent, the power is 2. And the next one is x to the third. How do we solve this type of equation? So I gave you the steps here. Step 1, you're going to make one side a 0. Well, this side is already 0, so we don't have to do that first step. Step 2, factor the non-zero side. So this is the non-zero side. We do factoring. And apparently this is trinomial. So let's break down. Let me draw the box here. We're going to have break down 6x squared. We can have 2 times 3 and x times x. Now break down negative 6. We have negative 3 here, positive 2 here. And make sure you verify the diagonals or the cross products add up to the term in the middle. Okay, I did see 1 or 2 students made mistakes in the factoring part. Okay, and especially on the first exam, there were a few. If you got a low grade and probably you had a lot of trouble with the factoring, okay, or you probably know whether you know how to factor or not. So if you didn't know how to do factoring on the first exam, make sure you try to do more practice on that, because on the second exam we have I think 4 or 5 questions. You still have to do factoring. Okay, all right. Again, factoring is a very basic skill in algebra class. So after we factor the left-hand side, let's copy the factors down. 2x minus 3 times 3x plus 2. So that gives us the left-hand side. The right-hand side, it will still keep it. Okay, the final step is set each factor equal to 0. So we set the first factor equal to 0, and we set the second one equal to 0. Why can we do that? That is based on this property. If the product of 2 numbers is 0, then one of them must be 0. Apparently, I have the product. If the product of 2 numbers, you can think of this as the first number, this as second number, is 0, that's is 0, then one of them must be 0. Either the first is 0 or the second is 0, okay? And then you just, get x by itself. Okay, subtract the 2. So I'm going to be a little quicker here. Subtract the 2, divide by 3. So there are 2 answers for this question. Okay, this next question is very similar. You would do the same way, but we do have to do step 1, make one side 0, because neither side is 0. So I'm going to subtract 4x from both sides. Okay, the right-hand side is 0. The left-hand side is the non-zero side. We need to factor it. Start with GCF. And in the previous question, there's no GCF. 6, 5, 6, nothing in common. X squared, no x in common. So that's why I just did a trinomial. But in this case, we do have x in common. Factor that out. You can divide them by x, and to get the other one, x third divided by x is x squared, and minus 4 equals 0. Okay, and then x squared minus 4, it's difference of 2 squares, because 4 is 2 squared, right? So we can write it as, break this down further as x plus 2 times x minus 2. So we're done with the second step. Now the final step is to set each factor equal to 0. In this case, we got 3. The first or the second or the third. Well, we really don't need the parentheses. Okay, so I can get rid of the parentheses. We don't need that. Now solve each one. Well, the first one apparently is already the answer. Nothing to solve. X is already by itself. Second one, we subtracted 2. The third one, we added 2. Okay, so we got 3 answers. If you have time, plug back into the equation to verify these are correct. Okay, now the last equation we have is the, it's a proportion. This is a special equation. Okay, it comes from 4.6. I gave you 2 different ways to do in class, but the quick way, if this fractional equation is a proportion, because proportion has a very good property, it's called cross products are equal. In the proportion, cross products are always equal. Okay, so we're going to use that property. Multiply top 1 times bottom x minus 3 equals the bottom 5x plus 1 times the top 4, and distribute. Okay, now we combine like terms. First, we usually combine. If you remember from the first exam, we always combine the x terms first, and then we decide which number to move. If I move x to the right, then I need to move 4 to the left to separate them. Okay, in the final step, we get rid of the number in front of x. So x equals -7/19. Okay, so that's the type of equations you are going to get. All right, the final question is long division. I noticed that a lot of students just put the answer there without showing any work. I don't know how you got those. I mean, if you, like I said, when you, all the problems in the homework, in the exam, you must show your work in order to get points. If you just put the answer there and you can't get points. Okay, I may give you like a point, 1 point when you take the exam, but you do have to show your work to get all the points. Okay, there is another way. It's called a synthetic division. If you do synthetic division correctly, I can also give you the 4 points. But the way we taught in class, the long division, okay, you do have to show every single step. All right, so let's go over this again. If you need more examples, say I have trouble doing long division. I know it's a tedious process, and I have more examples on Blackboard, so you can either watch the class video or more examples. So there are these 3 steps. First, you divide the first term of the divisor into the first term of the dividend. So pretty much it means, so when you're trying to determine the quotient, similar to long division of numbers, you're going to try to figure out how many times, let me highlight, this goes into that. Okay, so when you just need to look at the first term in order to figure out quotient. Okay, so divide x into 2x third. And that part, you can do it in your mind, or you can, let me write it here, you can do it on your scratch paper. So when you divide x into 2x third, well, 2x third divided by x, so we get a 2x squared. So that is the quotient, which would go on the top of, squared. That would be part of your quotient. The second step is, so how do you figure out what to put on top, or what the quotient is? You do division. Divide x into 2x third. See, if you look at this symbol, what does this mean? It just means division, right? So you're just going to divide, x by into 2x third. And usually we divide them vertically. That way it's easier to see. Okay, now we are going to, second step is multiply. We multiply 2x squared with the divisor. You can do it in your mind. If you can't, write it down. So 2x squared divided by x minus 1. So when you do division in the first step, you can ignore the second term. You can just take x divided into that. But when you do multiplication, you cannot ignore the minus. You have to multiply with both of them. So that gives us 2x third distribute minus 2x squared. So again, if you wonder why we're doing this, I mean, how can we just do it this way? And it's very similar. It's imitating the process of long division of numbers. So again, watch the class video. I have a comparison. I have an example of numbers to show you why every step is like this. Okay, so now we line up whatever we got from step 2, 2x third minus 2x squared. Okay, the tricky part is the third step, subtract. So although I emphasized many times, I think I still saw like 1 or 2 students maybe missed the sign right here. Okay, so remember we're supposed to do subtraction. It's going to be minus between these two. It's going to be minus between these two. And apparently 2x cubed minus 2x cubed, they cancel out. But right here, it's x squared minus negative 2x. How do we do x squared minus negative 2x squared? We got to do keep, change. So they will be changed to plus. So it's not going to get you negative x squared. I guess probably more than one student. I saw a few students had negative x squared. And well, there's another minus sign between them. So after you do keep change, it's going to turn both into positive. So it's going to be 3x squared, not negative x squared, okay? So again, that's the part. If you got negative x squared, I circle right here to remind you you're supposed to do subtraction. Okay, so now we just repeat the same 3 steps again until we run out of the terms. So we're going to divide x into, let me highlight this. So we divide x into 3x squared to figure out what the quotient is. So how many times x goes into 3x squared? So we divide 3x squared by x. That gives us a 3x. And that goes into the part of the quotient. The next part is to multiply 3x with the divisor, x minus 1. Distribute, that gives a 3x squared minus 3x. Okay, and we line up with what we have. So again, we're supposed to do subtraction. I'm going to put a minus here and a minus there. 3x squared minus 3x squared, they cancel, but negative 2 minus negative 3. Keep, change. So we end up with 1x, or just x. Now bring down the last term 5. Repeat again. So this time we divide x into x divided by x, it's going to give us a positive 1. Okay, so again, the process we did is x divided by x. That gives us a positive 1. Let's put it up there. And multiply 1 with x minus 1. It's just going to be x minus 1. So finally, again, it's not a 4. I think there's one student who got everything right except the final step and put the answer 4 there. But remember, we're still doing subtraction. Minus. So you're going to do keep, change. So the answer, the remainder should be 6, not 4. Okay. And the other way to write the answer is equals, this will be equal to 2x squared plus 3x plus 1 plus 6 over x minus 1. Okay, so that the other either you mark in your answer that's the remainder, that's the quotient, or you can write down the quotient plus remainder divided by the divisor. Okay. All right, questions. Okay, no questions? I think because we still have a little bit of time, so I am going to, normally the review class, I don't give bonus, but we still have time, so I'm going to give you a few bonus questions to do in class, okay? So it's going to be similar to the questions we did in the practice exam. So if you want to check whether you are ready for the exam, you can try to do this.